Bismillahirrahmanirrahim. Assalamu alaikum. This is a very short video about application of safe stopping side distance. It's just how this the concept of safe stopping side distance can be applied in various ways in highway geometric design or even in traffic engineering. So there are two problems that I am solving for you. I hope this will clear your concepts. To start with, uh, there is problem number one, in which we have to place a toll plaza sign at a distance, at some distance, which is we need to calculate, so that a vehicle traveling at a speed of 70 miles per hour can see that see that 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 has to stop beyond the last car or beyond the queue lane to pay for the toll tax, and the driver must be informed around 300 feet or 100 meter before uh, he arrives at toll plaza. A very simple problem. All we need to do is to first take the data. So as I've discussed most of the time, uh, engineering problems are solved by in three steps: the data, formula, and then calculation. So from this data, what we have is we have got this design speed at 70 miles per hour. That is time t. Though it's not given, then it's a perception time. We all know it's 2.5 seconds. And the acceleration for safe stopping side distance is feet per second square. Now the formula is always for first we have to need to calculate safe stopping side distance. This is a peeved distance, perception, intellection, emotion, and evolution distance, plus the braking distance. Peeved distance is simply 1.47 times V into T. 1.47 is a conversion factor that convert miles per hour to feet per second. And then the braking distance, has been taken from H2 policy of the design, and the D, this can be calculated from this formulation, where G is the grade, and this G should be, can be, also should always be taken for -1. Second thing is, if not given, this G is assumed to be 0. So in our data, since there is no mention of the grade or a curve, that's why we will take this G as a 0. The second formula we can derive from this thing is that if the vehicle has to stop from this point to this point, this is SSD. And if we have a common reference point, then if we add triple SD plus 150, that will be equal to the question mark plus 300. So that's how this equation has been written. Obviously, in this calculation, in this problem, we at triple SD, we will calculate from other formulation. 300 and 150 are known to us. So from this, we have calculation, we calculate peeve distance at 257 feet from the formulas, brake distance 470, and triple SD comes up to 727. So, and if you apply problem formula 2, we'll find where this toll plaza should be placed around from this calculation, from this data, it should be placed around 577 or make it say 600 feet from or 200 meter from the toll plaza. So this is first example. Now we move on to the second example, in which we have to calculate a time, a signal green time, so that a car traveling at a speed of 40 miles per hour could pass the green light. So let's see. We have to assume that the car length is 15 feet. Normally, it's a Corolla car uh, in Pakistan. That is around 15 feet 4 inches in length. So I'm just taking this 15 feet. Normally, a distance is 100 meter is required from a stop line to intersection. Uh, so this is again converted into feet around 300 feet. The intersection will obviously vary, but for this example, we have taken as 100 feet. Let's come to the diagram. There's a car, it's moving at 40 miles per hour. So if there is a red signal, it will have to stop. So again, so this is my safe stopping side distance. And from safe stopping side distance, there is a stopping line that is 300 feet. So we'll take this as 300 feet. And if the vehicle has safely crossed, it must have, have crossed this signal by its its length. So actually, the vehicle should have passed this 15 feet as well. So let's see what the data we have. The design speed 40 miles per hour. Time is 2.5 seconds. A is 11.2 that we have covered this thing. I think there's problem in this unit, but we all know what this relation is about. There is a stop line distance 300 feet explained in the previous diagram. Intersection width is 100 feet and the car length is 15 feet. There are three formulas that will be used in this problem. One is again the convention triple SG. So we all know the speed distance plus braking distance. So we'll find triple SG. And once you know this triple SG, we will add them 300, 150. Let's go back to the diagram. It's triple SG, then 300 plus 150. So this is the all distance a vehicle has to travel in some time. So for that, that time is obviously we are calculating. So that's why we have taken. And once we have done this, then obviously we know S distance is velocity into time. And if we want to find time, this is distance upon 1.47 V. Again, 1.47 is converting the mile per hour unit to feet per second unit. So that's it. We have calculated triple SG, 147 plus 168. The total distance comes out to 730. And a vehicle will need a green time of 12.4 seconds. So again, this is one aspect. Actually, we know that the green cycle time is also calculated from the saturation flow, the flow in traffic, but it's one of the application how if you design signal, this can also, whatever you have calculated from the other formulations of signal time, this can also confirm, you can, reverse back to this calculation to confirm whatever the time, green time is available. It's applicable. So it's a confirmation of what we have calculated from other formulas of conventional signal design. So this is all I have. Thank you very much. And I hope this have broadened your concept and have explained how triple SG can be utilized apart from the curves, the design of horizontal curves and the vertical curves. Jazakallah khair. Thank you very much.